framing. We'll discuss data collection understanding, data analysis preparation, a little bit of model building. Now I'll jump and there are still parts under model building, the predictive and prescriptive analytics. We will jump over this to something that is related to descriptive analytics and communication, reporting, and presenting, which is data visualization. A very, very, very important subject. We have a class that is devoted for data visualization. There are careers that are only devoted for data visualization. So the gentleman who will present to you as a guest speaker, all he does is data visualization. So this can be something you do for all of you. It's very important to know. What I'm going to do is just to give you some information about it, and then you can specialize in it later in your life if you need it. And I doubt that anyone won't like data visualization. It's really maybe the most fun thing that you do with data. As I mentioned, it's a new field and it's a specialization. So the whole concept is about presenting data in a way that the human brain will perceive faster. Even people who are not very technical will be able to understand. And quickly understanding patterns and identifying some interesting information from the data. That's the goal of visualization. Taking this columns and rows and making them a picture or a chart that will present them correctly. So you can identify the pattern and get the insight quickly without the need to go into every cell and try to analyze the data. We are not wired, and I'll show you an example, to read and identify trends and interesting information from a bunch of text or a big Excel file. Our minds are not wired like that. However, we were created or evolved, our mind doesn't work like this. However, our mind works better and can see trends and interesting information and hidden patterns from pictures and charts better than they do with text, big text, or data points in an Excel file, rows and columns. However, the computer which we created is better in understanding and identifying patterns in a tabular form data, which is columns and rows and data points, than being able to read a picture or a chart. Now, computers are becoming better in reading pictures and charts through artificial intelligence because the scientists are trying to make them see the things that we see, or trying to mimic the brain, the human brain process. So we use the computer to do that quantitative analysis for us, and we give it the instruction, but we can look at pictures and charts and identify patterns. And this process that happens in business when you are, for example, a consultant or a team member in an organization, and you get to the point that you want to present, and all you have is 10 minutes. You cannot just throw text there and Excel files and then go through number by number and explain the numbers. You might only have to do 3 to 4 charts and go tell a story. That's the important part. Telling a story quickly that a CEO will understand, and most of the CEOs and the C-suite people, they don't really like or have time to go into the specific details and going into the weeds. So you need to give them a qualitative, exploratory kind of a presentation through visualization. That's the value and the relevance to this day and industry. As I mentioned, data visualization is qualitative. It's not about specific numbers and comparing numbers. It's about explaining a trend, explaining a chart, explaining a picture maybe, and trying to identify the patterns that are in the data through this kind of practice and visualization. And it helps us, even when you use it on text to identify any hidden information that the regular quantitative analysis might overlook. So if you look at this Excel file or this table, can you identify any pattern? Assuming that you don't know the data and you didn't work on it yourself. Just by looking at it,
Yeah,
you can.
because you can see how sales goes up over time linearly as it.
Yes.
Yeah.
So you can see some positive correlation between both. How about this? Which one is easier to see? Reading the numbers or looking at these two charts and seeing quickly without even trying to find the values in each cell. Just looking at the chart, 1 second can tell you one is going up and the other is going up in the same direction, so I can see correlation. That is how our minds are wired. To see information in picture, in visual, more than. That's why Facebook and those kind of things are very famous. I think one of the reasons. Because we are so attracted to this kind of information they provide. A lot of pictures, a lot of videos, a lot of pictures. That's how our attention is dragged, usually to this kind of information, more than numbers and text. And for example, if you read the speech of the president, you won't really just reading the text, you won't find any pattern. Quickly, maybe you will remember, oh, he said people so many times, but you can't easily find these kind of patterns or the frequency of words that he said just by looking at the full speech at once, text. But if you look at the visual like this, quickly you will say, oh, okay, he focused a lot on national issues, American people. You will know what he focused on just by looking at a picture and quickly without reading the text. Now it won't give you the full story, but it will tell you the things that you need to pay attention to, the things that you need to focus on. That's why we need to accompany data visualization with the full spectrum of analytics, predictive, prescriptive, and descriptive. It's not enough by itself, but it is very important. And it is a very old practice. So this is a visualization for the campaign for Napoleon Bonaparte, which was the leader, the French leader. I don't know if this is the pronunciation that I know. I don't know if it's English, of course. That was but his name is Napoleon. So that great leader, he made a very significant campaign in Russia and he lost miserably. But this visualization can show you how humans try since all time to try to visualize and represent data into pictures and charts that can easily present what happened. So you will see multiple things in this chart. You will see the direction of the campaign. So the light gray will give you the direction going forward, and the dark gray will give you the direction going backward. The thickness of this chart is the number of proofs. You will see also the locations, the cities. You will see the temperature, the distance. So many things now presented in one picture. Imagine that you have the actual data behind the scenes. Then you will see tens of columns and millions of rows. That means nothing to you. But now you can see, oh, he started with a big number. When he reached Moscow, those numbers were reduced a lot because the Russians were fighting all over the place. And then when he went back, he ended up with very few numbers. So he started with this huge army, and he ended up with only those. So many people were killed, and it was a miserable result. I can say this story just by looking at the picture. And he went to this city and that's how much he, the distance that his troops traveled. All this you can get it just looking at the picture. Very, very impactful. Winston Churchill also in World War II, this was his room. histograms and charts and trying to identify data and trying to identify pattern and find quickly intelligent information and interesting information that he can use in a very fierce war against the Nazi army. So you see, it's not new, but recently it was evolved, and it was evolved to a new kind of art and science with the tools that are now provided by technology companies. You don't have to do a chart by hand or in Excel. You have Tableau and you have R, and I'll show you in a few how you can do those kind of things on your own. So if you like this session and if you like the data visualization class, which is a class given by Dr. Nestorov, I would say search for jobs that is only focused on data visualization, because you will find lifelong job that is so much fun if you really like it. It's very much needed in every industry. And the point is, as you see, there is no calculation here. Definitely there is calculation to draw the chart, but when you're looking at it, you're not looking at numbers. You don't care really about the numbers. You're trying to compare things and see trends and see directions of an event, not the actual numbers. That's the art of it, and I consider it also data visualization. So we are talking about France in this session. That's the subway in Paris, the old map and the new map. So you can play a little bit with data visualization and reduce the clutter. So this is so busy map. They were able to give the same information in a more cleaner way, just by curving the lines a little bit. Now you have more white space and you can see better. That's something, as you're creating your visual, you should always think about that. Is it too busy? Do people have to look at it for a long time to understand it? Can I understand it just by looking at it quickly? I should ask myself those questions before I can present my information. And always remember, when you're creating your visual, you have been looking at it for a long time, so you will definitely understand it, because you've been doing it. But imagine and think and put yourself in the shoes of somebody who knows nothing about the problem and just looking at your chart. Are they able to identify what you're trying to tell them? Keep asking yourself this question. One kind of visualization which I really don't like much is infographics, but it is there and it's very much used in the industry. Not very scientific. It's a couple pictures and it tells the story. It's good for, explaining some phenomena in a fun way, but when we talk about scientific work and analytics, we need different kind of visualization, not infographics. The visualization that we talk about in this class and we will learn in data visualization. In terms of tools, these are the data visualization tools, and there are tools just for data visualization. Example, Tableau, which is a tool we will touch a little bit about in this session, at the end of this session. And I haven't seen any company that, so far, my experience, that doesn't know or use Tableau, or willing to use Tableau if they have money. That doesn't mean if you know Tableau, you know data visualization. No. If you know Tableau, you can visualize quicker. But data visualization is a mindset. It's, as I mentioned, art and science. It's ability to play with the data and identify the things that are most important to show. So, in your project and presentation for this class, when you're creating your presentation, you will put some visuals for me, because only you have 15 minutes to present. It should be those information that are in your chart should be the most important, the ones that will tell me the most interesting things, because I will be reading your report. Having a tool like that will enable you to do that quicker. But the logic behind the visualization, your skill of how to play with the data is what matters. Because today we have Tableau, Tomorrow we might have Tableau, we might have something else. What matters is those kind of basic skills that you should master, not focus only on the tool. I'm not teaching you Tableau, I'm teaching you data visualization through Tableau and others. So I will change a little bit in this session. I will continue the lecture through the lab, which will explain the remainder, almost half of the lecture through the lab, and then you can later read the slides, or you can ask me any questions as we go. Okay? So let's open the lab 06, please. You will find it in the assignment. One second. Create a folder, and I will have to sorry. Create a folder called lab 06 and download everything in that. I will zoom in for the people in the back, and you let me know when I'm going to start. Good or more? More? A little bit? One click? All right. You good? At the end, we're good, guys? You can see? Okay, good. So, this session and this lecture, as I mentioned, will be describing for us the process and some important concepts for data analytics, and we will use both Tableau and R. Here we will use R, and then later I will open Tableau for you, and you will see how you can use it for data visualization. The first thing that we have to do in every lab is what? Is setting my working directory. Since the file is saved in one folder with everything else, then I can set the working directory to source file location. So the first thing that I will do is to read the marketing data. As I told you before, the best first step to work in R or in Tableau or in any other tool is to go to the source, closer to the source, and do some evaluation and assessment of this data set. So I will open, this is the source is me. I gave you this CSV file. You open it, just open it and take a look at it. What is in there? How many rows? What are the columns? Before we start working in our friend RSP. So I have 20 rows, and that is the same data that we talked about before. Case number is just the case study or that observation. And that's the state where the sales happen. And then here I have in each case or in each observation or in each case study, the sales amount for the company we are studying, how much they spend in thousands. All these numbers are in thousands. How much they spend on radio ads, how much they spend on paper ads, how much they spend on TV ads, how much they spend on point of sale ads or promotion. So it's clear now, I can close it and go back to it. If I read, I can see 20 observations, so we're good, no issue, and I can see that the headers are read also correctly, so I don't need to skip, everything is good. The first line is creating my data, the object, by reading the file. The second line is showing the first few lines of my data, the object, which is the marketing funnel. So I want to create a chart. So that's why I said it's better to explain this section through the lab instead of going through the slides. Now you can go with me and then read the slides if you will understand it better. I want to visual and create a picture, whatever you want to call it. That's one of my favorite professors. The accounting people, this is the man. He is wonderful. He teaches accounting.
Oh, Professor Lee.
Dr. Lee, you know?
Yeah,
Lee?
Dr. Lee's the best.
So I took his class, although, I don't like accounting much, but he made it so much fun. And I did rather well. All right. So what we want to do, you have in the data state information, right? I want to create a chart that will tell me the number of cases or the number of those of rows you can think about in the data per state. How many each state was repeated in the data. So I can identify where I have, in which state do I have the highest number of transactions or the highest number of cases in this data. So what should I do? What kind of a chart should I use? One good chart for that is called a bar chart, which is just bars that represent the number that you're trying to see, and that's on the y-axis, and on the x-axis you have the categories. And the categories in this case are the states. Since the state is a categorical variable, and what is a categorical variable? Who can tell me what is a categorical variable? Nobody knows what is a categorical variable? Let's talk about this. Yeah.
So categorical variables, they I don't know how to say it. Like they're like descriptions, or like they aren't like numeric. Yeah.
That's a simple way to do it.
Yeah.
Numeric and non-numeric. The non-numeric are categories. So I have a categorical variable, which is the state, and I have numbers that I want to assign to each state. So I need to group the chart in terms of categories, and then I need something to represent the numbers for it. So bar chart is good. Each bar is one category, and the length of the bar is the value. So how can I create a bar chart in R? Before I create the bar chart, I need to extract the column state. So now I have state, which has all the states in the data. And then I need to do a frequency table, and the frequency table will be just listing each state and how many times each state was repeated in the data. There is a function for the frequency table. It's the table function. So I'll create an object. This object is called state table, and I will use the function table on the field state to create the frequency table. Okay, this is the frequency table. It's telling me that the state of Arizona is listed 3 times, state of California is listed 3 times, and so on. And if I look at my data, I will see that Arizona 3 times, California 3 times, etc. All right? Now that's a way I have what I need. I have the numbers and I have the states. But a chart will give me. Imagine that you have here hundreds and hundreds of categories. It's very hard to read it in a table, but in a chart it could be easier. You will see the longest one. At least you will see that everything is similar. Or do I have few that are too long, or I have high frequency and few that are low frequency, and everything else is in the middle? A chart can help. So a chart can be, as I mentioned, a bar chart, and the function you have to use is called bar plot. This is the function. Bar plot, you create it, you use the table, the frequency table that you created inside bar plot function, and you create a chart which is this. Compare this view to this view. I think a picture is better. And I can see quickly, all right, that I have the one height state, and then most of the other states, they were repeated 3 times, and I can see very comparable numbers. So I have kind of uniform distribution. That is the interesting information that I can say from this chart. I have a kind of uniform distribution in terms of number of cases in each state. All right, so the first question in here that you have to answer is to use the chunk or the code chunk below to repeat the same chart, but this time enter the title using main inside the function bar plot gives you the opportunity to have a title for your chart. Xlab and Ylab will give you the opportunity to have a title for your axis. This is the x-axis and this is the y-axis. You want to call this one maybe states. You want to call it state's name, whatever you want to call it, and here you can say number of cases or frequency, whatever you want to say. But that, what I'm trying to tell you here, that never create a chart without a title and never create a chart with axis without title. Because again, you know your data, you're working with your data for 2.5 hours and then later at home, but somebody who is new to your data knows nothing. You need to tell them as much information as possible. So the chart will tell them some information, and the namings that you want to add to your chart will add more. All right. So as you can see, another feature and characteristic or function that you can use in data visualization is sorting. Sorting is very, very important. Looking at this chart like this can tell you some information about the frequency. But if I sort from highest to lowest or from lowest to highest, it's going to be more elegant when you're showing it, and also will show you interesting information even quicker. So I don't have a button to sort in R, but I have a function that can help me sort. So that function is order. So I want now that frequency tables to be ordered from lowest to highest or from highest to lowest. I can create the frequency table again, call it again, and use the order function to sort the values inside the frequency table. So if I run this line of code, now I have the same table sorted from lowest to highest. Then I create the bar plot or the bar chart on the sorted data. That is better. And imagine you have so many categories, it is better always to sort. Right? I can see I have 2 states with low number, and quickly I can see that majority of the states are repeated 3 times, and I have one more state that is kind of not an outlier, it's a little bit higher than the other, which was repeated 4 times. Again, always imagine if you have so many categories or so many states, when you sort, it will give you a very nice view. When you don't sort, you feel like the chart is going all over the place and I can't tell what am I looking at. Sometimes you need to sort, sometimes not. You have to analyze it case by case. But that's how you sort in R using the order function. And usually you have to put the bracket around the order function to work. So if you're sorting anything, you just open the bracket and then write the order function, and inside the parentheses of the order function, you have to include what you want to order by. In this case, I want to order by the table itself because the table has only one value, which is the number. I only have one column for sorting, which is the number of cases. But in other situations, you might have a table that has multiple fields and you want to sort by only one. Yes?
How would you flip it? So like high and low.
You can do descent.
Okay. You just where would you put this in?
You can use another function, or in this one, let me show you. There is inside order one sub-function that you can call, which is decreasing. By default, decreasing is set to false, so it will go increasing. If you want it to do from the opposite, you write decreasing equals true, and then you do it like that. So usually, inside the function, they give you all the details in the help that you might need. Sometimes you have to blend another function, but usually with those basic functions, they have everything. Best way to do, question mark, the function, parentheses, and then you can get all the stuff. And also, you can have an explanation, right? Decreasing. Decreasing is logical, which means it will be true or false. It will tell you how the sort order, whether it's ascending or descending. So it explains everything for you. I usually, in the homeworks, I give you the basic stuff for each function. But each function has so many choices to make, like bar plot. If you just do bar plot table, it will give you the bar plot. But you have main to give you the title, you have xlab to give you the title of the x-ax, you have ylab, you have ylim, which give you the limits for the x-ax, the y-ax, and xlim. So you have so many things. Always use help, it will tell you the story. You will rarely find somebody who knows everything by heart. It's a nice documentation. Did that answer your question, my friend? Good. Now, another technique to do visualization is our friend, very close to my heart, very, very close, is the histogram. Anyone who likes analytics and statistics loves histogram because it tells you the distribution in one picture without all this mean and median comparison and standard deviation and all this nonsense. One picture can tell you the whole story. So, but why do I need to think of histogram? I have, for example, the variable TV in my data. I want to look at it by its own, without including a category. I don't want to look at TV per state, or TV spend ads spend, or TV ads spend by state. I want to just look at all those 20 observations for TV spend and visualize it. So I don't have categories. I cannot use bar plot, because bar plot is supposed to have categories on the x-axis. What can I do? I need some kind of chart that fits one variable, which is numeric. One of them, which is very nice and powerful, as I mentioned, is the histogram. But what does the histogram tell me? It tells me the distribution of values. So I will be able to look at those 20 data points and see, are they all close to each other, or are they very variable? If it's the first, then I can say, well, in every single case, we have spent almost the same on TV. If not, then we are spending in a very abnormal way. Every time we're deciding on a number to spend on TV ads. That is insight that you can get from a histogram. If the histogram is skewed to the left or to the right, I can see that most of the cases had similar spend, but only few of them had very low or very high. If I'm looking for this kind of information, histogram is the best. So let's try to look at the histogram. Now I extract that column TV from my data, and now I can look at it. It's integer, and it's in here, and it has 20 observations. Perfect. And now I use the function hist. The function hist will create a histogram for this value. Again, inside the function hist, if I do here hist, you will see million of things that you can define. The title of the chart, the name on the x-axis, the name of the on the y-axis, the bins, which I will explain in few, so many. So, this is my histogram. How is the histogram different from bar plot? They are both of them, histogram and bar plot, has bars and values. Why this is different? Why is it a different function and different charts? It's bars, values, and that is bars and values. Yes, sir.
Isn't it because you're displaying, I might be getting this wrong, but like integer and ratio data at the same time? Or like because TV is ordered from 250 to 280 and then you're trying to see the frequency within one of those number ranges, so...
You are getting very close.
Okay.
In the bar chart, I have categorically state, maybe name, any categorical variable there that I want to count the frequency by. In a histogram, I don't have a category, but I have bins. Those are called bins, which are ranges for the values of TV Spain. And in each bin, I calculate the frequency of data points. So, this is telling me that I have spent between 250 and 255 on TV advertisement 6 times. 6 times I spent between 250 and 255. I have spent between 255 and 260 3 times. I have not spent any time between 260 and 265. This is the kind of information I get from a histogram. I don't have a category, I don't have state, I don't have anything I'm counting by, but I have bins that I'm counting by. And the histogram decided on those bins based on the values that are found in the field TV. So it decided that each bin will have a 5-point length from 200 to 205 on 560, and therefore I will have the how many bins? 1, 2, 3, 4, 5, 6. That is, if you give R a different column or a different variable with different results, it might end up with more bins or less bins. So it decides on the best number and length of each bin based on the values of the variable, but you can also specify the length of each bin yourself. If you don't like that, I'll show you how you can do it on the phone. But the point from the histogram is I'm getting frequency for the value of TV spent, but without using any kind of a category. That's how I use it. And it tells me the distribution. I can see somehow, it's hard to tell the distribution here. Probably that bin is too big. If I split it, it might tell me better. I can drill down into the distribution and see maybe more results. Now this is telling me it's kind of uniform. I don't see a normal. I don't see much skewness. But maybe, let's drill down and see. And change the bin structure, and maybe we can find something else. Read those details that I put here. It's very important, as important as the text in the lecture, the PowerPoint. Because I spend a long time documenting things here for you. As you're working through the code, you're thinking as well. So many things that the histogram differ from the bar plot. One is the x-axis, or axis, is numeric. There are bins in here. in histogram, but in the bar plot we have categories. Usually the bins are made up from a continuous variable, but not necessarily. What is the difference between continuous and discrete? What is continuous first? I need somebody. Sorry. Yes, sir.
Continuous, it's like the difference between discrete is like discretes and steps, where continuous it's more like a spectrum, like measurements can fall in between.
Yeah, it can take any value between two values. However, discrete can take certain values between two values. So the bins is assuming that these bins can take any value between 250 and 200. And that's true. So you can spend 251, 251, 0.1, 0.2, 0.3. But also histogram fits discrete data as well. Alright? Because you can calculate the distribution for a discrete variable or for a continuous variable. But usually it is used for continuous. But I can also use histogram for the count of cases that I have done. And it's no problem. All right. And then, as I mentioned, the hist function calculates the frequency in each bin, but the hist function creates the bin by itself and decide on the number of bins and the length of each bin. Now you have to know something. This bin mean above this bin mean above than 255 and less than or equal to 260. This bin mean above than 260, less than or equal to 265. That is the case for every bin except the leftmost bin. The leftmost bin is greater than or equal the minimum point, less than or equal the breakpoint. So it's greater than or equal to 250, less than or equal to 155. So it includes both, but each other bin includes only the second breakpoint. Okay, and if you examine the data and you open the file, you will see exactly these frequencies. You will see that you only have 6 between 250 including 250 and 255 including 200. You'll see 6 rows with those values under TP. And that's what the histogram is trying to do. Now, how can I change the bins? And why do I need to change the bins? I can use this parameter inside the hist function, which is called breaks, to specify one, the number of bins, or the values of the breakpoints. Breakpoints are, those are breakpoints. 250, 255, 260, 265, those are called breakpoints. Number of bins are the number of bins. 1, 2, 3, 4, 5, 6 in this case. So I'm telling us, please create for this data 20 bins and create a histogram. Now I have a better distribution. A split, instead of having one bin and one bar between 250 and 255, now I have 3. So I have more detailed distribution, and now I can see that kind of uniform distribution better than before, because there's more detail. Now, which number of bins is better? I don't know. You have to test and try. It depends on the variable you're looking at. That's why there is an art and science. The science is those techniques, but there's no one best answer. It depends on how it looks. But in fact, I don't have 20 bins. I have 16. But why? I told R I want 16. I want 20. Let's try do something else. Let's try 16. Giving me the same result. Because R is stubborn. It doesn't just get what I tell it. this number of breaks that you would enter inside this function is a suggested number of breaks that you want. Then R takes that number, looks at the values in the variable, and decides on the best one based on your input and the values. So sometimes you tell it I want 20, it gives you 20. Sometimes you tell it I want 20, it gives you something else. But what you can use breaks for is to increase or decrease the number of bins. If it started with 6 bins as it did by default, you want more, just put 20 and see how much it will be. Another technique is, so you can get exactly what you want, you can specify exactly the values of each breakpoint. Maybe I want it to be 250, 253, 256, 259, and so on. If you want that, you can do this also using break inside the hist function, and this is the line of code that you do. Now, if I do this, it gives me 10 bins because I made each bin a length of 3, and I have the total length or range is 30 from 250 to 280. I have 30. 30 divided by 3, I have 10. So then I have 10 bins. If you think 10 bins is better, you can do that by specifying the breakpoints. All right? Basically, what we're trying to say here is not just R and sophisticated R, is to say histogram is a good for one numeric variable if you want to look at distribution. So, true or false? This is normal distribution.
False,
Why?
because it's not a bell curve.
Ah, yeah. True or false? This is triangular distribution.
It's false.
You know what triangular is?
Yeah.
It's like normal, but it's triangular. It's not. True or false? This is 100% uniform distribution.
False.
False, because if it's 100% uniform, I should see the same exact frequency in each frame. And I don't, because what I'm seeing here is this, and then this, and this, and this. What kind of distribution is this? Funky distribution. Right. Crazy distribution. But it is. Because you usually, when you're looking at 20 data points, you can't see the true distribution of the population. Because it's only 20 data points. There's a small sample. It's hard to infer the distribution of all your TV spent in all your life of the company. That's why you have to increase your sample. And if we look at instead of 20 at a million case, then you will start seeing some of those common distributions. The uniform, the normal, and the Poisson, which is exponential and other kind of common distribution. So instead of calculating numbers for identifying distribution, you can have a picture. So I want you, please, to create a histogram for another variable that is also part of your assignment. You have to do it on your own. Everything in red, or here will be blue, but when you do preview, it will be red, will be the things that you have to do. And I asked a question. Can you tell, for example, here, can you tell me, just looking at this, the total amount of TV ads spent?
Huh? No.
Look at this chart and tell me. The total amount of TV ads spent, can you tell me that? You have an answer. You're right. No? Not you. Yeah.
I just added it all up and I got 20.
20? The frequency is 20, correct. Because we have 20 data points. And basically this is telling me you have 3 data points where the spend is between 250 and 253. And this is telling me you have 3 between 253 and 256. So 20 is accurate. What I'm asking is, can you tell me the total amount of TV ad spent in the total 20 data points?
Mm-mm.
Okay.
Can you do like an average?
Good. How?
Wouldn't you, like, I would do it like this, I don't know if it's right.
Yeah.
Multiply 3 by 250, 3 by 255, and divide it by 20.
Yeah. So why didn't you say 3 by 253? Because it could be, right?
Yeah. I mean, isn't that the average though? This starts from 250, so it could be
Yeah.
smaller.
Why not 252? Why not 254? But you are actually very right. I cannot tell the exact amount that I spent in the total 20 homes, but I can tell some range. So that is the main difference between quantitative analysis and qualitative analysis using data. We're not here about exact numbers. We're here about some pattern, some distribution, shape of my data. But that's exactly it. You can infer some numbers from a chart, but not all the time you can get the exact. All right. So there is a similar tool or a chart that can behave or also give me the same thing as a bar chart, which is pie chart. And instead of having bars, and the length of each bar would be the value and category on the x-axis, the pie chart will be like a pie or like a pizza, and each slice is a category, and the size of the slice is the value. So I can look at this count per state or frequency per state using a pie chart instead of a bar chart. The function is called pi. Very intuitive. And now it gives me, you can also add the numbers. If you do question mark pi, you will see how you can add the numbers. The question I want you to think about, and you will, at the end of this, you will see, is this better or the bar chart is better? For the same thing, you're trying to visualize the same thing. It's the count per state. You have the option. You have so many charts. You have to pick the right one for the right case. I look at the pie chart. It is telling me Arizona has high number. California has high number. Florida too. Michigan. Can't tell much. Can't compare very much. Imagine if I have 20 categories. How would the pie chart look? Can I compare that? No. So the pie chart, when the categories increase, are not a good tool. Then I can go to a bar chart. If I'm doing percentages from each state, then a pie chart can work. If I have a few number of states, you have to make that hard decision by looking at your data, having a chart, and see if you can get what you need from it. It's not about how beautiful it is, it's not about how meaningful it is. But it is a good tool. All right. And here there is a question about pie chart, you have to answer it. So we talked about one variable. Everything we did so far is one variable. Either one variable we are counting for categorical, or we're looking only at the one numeric variable. We have another situation and another thing that we need to analyze during our descriptive analytics. And now we are still in the descriptive, which is the relationship between two variables. Very important thing that you have to do. And happy news, your project is mostly about relationship between variables. If you read the description, and please read the description, read the data, and start working from now, so you don't feel you don't have time. It needs a lot of work. So please start reading and preparing for the project. But why do I need to know relationship between variables? One, it can tell me if two things are moving together. One increases, the other increases, or one increases, the other decreases. This can help me use one to predict the other. Or just describe the situation, because I am now in the descriptive analytics. And have some preparation for the predictive analytics.
Because those variables who interact heavily with each other, that means they have high correlation, are very good candidates to be used in a predictive model. Because if the two variables has no relationship with each other, I don't have to put them in one model for prediction. They won't provide any value, right? So this kind of quick analysis for relationship can be done also through data visualization, or can be done through quantitative descriptive analysis. I can find the relationship between two variables, the strength and direction of relationship between sales and radio, for example, by calculating something called correlation coefficient. And I will show you from the slides now what correlation coefficient is. Most likely you have studied it in your statistics. The correlation coefficient tells it's a measure between -1 and 1, and tells you the strength of the relationship and the interaction between two variables. If it's 1, that means they are perfectly positively correlated. If it's -1, it means they are perfectly negatively correlated. So that is good. There is a number that can tell you something about the relationship. But why not identifying a relationship through a chart? It is faster and easier, and probably can provide more information. That chart is the scatter plot. How do I create the scatter plot? It is the same function that you have used to create a plot for one variable. You can use it now, but inside the function, you will list two variables. So I want to create a scatter plot between sales and radio. I want to map sales and radio together on one chart and see the relationship between sales and radio. Now I can see that there is strong correlation. As radio spend increases, sales also increases. They are almost linear relationship, strong correlation. And that means that spend on radio causes sales to increase.
No.
No? Why no? I can see it.
Correlation does not equal
It
causation.
is never equal. Maybe, not necessarily. You're right. That's a trick. Correlation is not necessarily causation. So I cannot say that who increase in the radio spend is cause it. It just happens to happen at the same time. Maybe it is radio spend is causing sales. Maybe they increase the sales due to something else led them to increase their radio spend for something. The marketing manager was so happy and starts spending more. Maybe there is some other reason that is causing both. I don't know. I know that they are both correlated, so I can use them for prediction. I can use these two, one to predict the other, or sales to predict radio, so I can correlate. I can use it. You identify this kind of information through correlation coefficient or through a chart like this scatter plot. Now compare this chart, which is the scatter plot. Again, you can create scatter plot using the plot function. And you have to enter the two variables in here instead of one. Compare this chart to this. It is the same information, but in two different charts. That's what I showed you last time. This is radio span, and this is separate. A scatter plot is actually merging these two together into one. So this data point and this data point became one data point in the scatter plot. And it gives you better information about the relationship between two variables than having two separate charts. So always, if I have to identify a relationship between two variables, use a scatter plot. And here I ask you, two questions here to create another scatter plot. And to answer questions and compare it to your findings from lab 01. Now, as we talked about in descriptive analytics, you have qualitative and quantitative. Whatever we have done so far, looking at the scatter plot and identifying the strength and the direction of the relationship, we saw that it is positive because both increase together and decrease together. And also, it is strong because it is very linear, somehow close to perfect linear relationship. You don't see the data set very far from each other, the data points. They're very close and as if all the data points are walking on a line. So that is qualitative. Quantitative, I can find the same information by calculating the correlation coefficient. This is the correlation coefficient between radio and sales. And you will see that it is almost close to 1, almost close to linear, and it is positive. So the same information you got it, it's good to have both quantitative and qualitative analysis to describe something. So let's go back to the slides and talk a little bit about correlation. So correlation, as I mentioned, measures the strength and the direction of a relationship between two variables. It helps me identify a predictive pattern between these two variables that I'm looking at, and it has a measure called correlation coefficient, which is between -1 and 1. As you can see, there are so many values for correlation coefficient. If it's 1, that means it is like this. Data points, they are perfectly linear, and I can say I have perfect positive correlation between the two variables. Here, you see the data points are spreading. They're not linear. They're spreading from each other, but they're still close to linear, so you see high positive correlation. Here I have low because the data points are very far from each other, and I can see that the correlation coefficient is getting closer to 0. And here I have no correlation, no relationship. And the correlation coefficient is 0. And then the same thing for the negative coefficient. Now, the direction of the correlation is identified by the sign or by looking at the scatter plot. You will see if it's positive or if it is negative. Negative means if one increase, the other decrease. If one decrease, the other increase. Positive means if one increase, the other increase. If one decrease, the other decrease. Strength of the relationship is the value of the correlation coefficient. Closer to 1, closer to -1 is the highest, closer to 0 is the lowest. Correlation is not causation. We talked about this million times. But how come correlation can help me predict one variable by using the other? At the same time, Hassam is telling me you cannot infer causation. So, if there is high correlation between value ads and sales, I can use radio ads spend to predict sales. But at the same time, I cannot say that radio ad spend caused sales. How can I use one variable to predict the other, and at the same time I'm saying that variable, the predictor, is not the cause? Because correlation is telling me that two things are happening together. They are coinciding. One event coincides with the other. They're happening at the same time. And that's all I need for prediction. For example, simple example. Every day in the morning, people go to work. So when the sun rises, people go to work. Correlation between the two events. Sunrise, people go to work. Does that mean people go to work because the sun rises? No. People go to work because they need to make a living, because they have fun at work. But two things happen together. So I can use the sunrise to predict when people can go to work. But at the same time, there is no causation. Do not confuse prediction and causation. You can find a perfect predictor, but it is not necessarily a cause. It's a predictor. It's just telling me that something is going to happen because I saw something else happen. That is not causation. This kind of analysis is very important in medicine. People used to confuse that a lot, and they start giving science and medicine wrong direction because they confuse correlation and causation. There's something called correlation matrix. Basically, if you have so many variables, like here we have 12 variables, you can do correlation coefficient and calculate correlation coefficient between each two. So if I have 12 by 12, that's the total number. I don't know why they wrote that. They know that I have a So it's a good visual to see the correlation between so many variables at the same time. Because you're not only doing this between two, you might be doing it between 12. So each one would be compared to the other 11. And you have to do this 12 times. So you will have something like that. It's a good visual. The darker the value, the higher the correlation coefficient. Or you can have instead the number, the value of the correlation coefficient, and you can't read it. Because you will have all these cells with numbers and you can't tell. But if you put colors instead, you will see, oh, I can see here high correlation. Those between 8 and between x8 and x2, there is very low correlation. Well, between x8 and x8, there is perfect correlation because I correlate with myself perfectly. Here is okay, you know. That kind of matrix is very helpful to identify relationship between many variables. Now, as you noticed, with correlation, something that we will discuss in related analytics called the line or the line of best fit. This line is the best line that represents the relationship between the variables. So, if the variables are linear, 100% linear, then this line is the best line. If the relationship between the two variables is 100% linear, then this line is the best line that represents the relationship because it's linear. But not every relationship between two variables is linear. I can find a line that best represents this relationship, and that's called the regression line. So I can use correlation coefficient and scatter plot to identify strength and direction of a relationship between two variables, but I can use regression line to quantify the relationship and turn it into a linear equation. Because when I say I am related to you using correlation coefficient, what does that mean? How can I quantify that? Then I use regression, which I'll show you how to calculate it, to turn this relationship into a linear equation, or sometimes non-linear equation. In our case, we will only talk about linear regression. So that is what we call the line of best fit. That is the best line that can represent a data set or a relationship between two variables, even if the relationship is not 100% linear. We are trying to simplify and find a line or a linear equation that can best represent the relationship. So as you can see, the regression or the best, the line of best fit can be the same for multiple data sets. Because again, this is an estimation. And if you remember, regression was one of the things when I put the chart of statistics at the beginning of the class. Regression was one of the things that I used to generalize from a sample to population. So this line is using the sample data and trying to create the best linear relationship for the population. Sometimes it is very successful, like here. This line is very close to my data points. Sometimes it is very hard to create a linear relationship or to estimate a linear relationship between two variables because the relationship is very far from the mean. Therefore, we might see the same exact result of the regression and the equation, but here it's not representing the data at all. While here it is somehow representing the data, here it is representing the data very well. There it is not, because the relationship is not linear. It's not even close to linear. It's not linear. So if I use a line to represent it, I might not be very successful. And if I use my regression to forecast, I also might not be very successful. So the linear regression is not the answer for every relationship between two variables. That's why visualization is very important. You look at the data and you say, I think a linear regression can be a good technique to represent the relationship. But if it looks like this, quickly you can say, this is too far from linear. Why am I using linear regression to represent this relationship? Just handle with care and visualize. All right, let's go back and do the lab. Here I use the layout function, and the layout function, I used it before, is to divide the view for the chart into more than one spot. If I want to have in my view more than one chart at the same time close to each other, not on the top of each other. I want them to be in the same view, one over the other, or one next to the other, or if I have four, I want to have all four of them in the same view. I use the layout function. So in this case, I want to provide for the variable sales 4 different visualizations. So I will separate the view in R into 4 2x2 quadrants. That's how the layout function works. I use the layout function, the matrix function, and here I specify I need 1, 2, 3, and 4 variables, and I want 2 rows and 2 columns. That's what it means. And then I plot the 4 charts, and they look like this. All together in one view instead of having multiple charts, one after the other. So looking at those charts, what do you think, which one is the best to visualize sales on its own? Is this good? Not at all. It doesn't tell me anything. Why? Because it looked at every single case and gave me the value of sales in every case. What does that mean? Nothing. There's no category, nothing. What about bar chart? What is it? 20 bars. What is it done? Maybe. I mean, distribution maybe, but this is better view. Right? Histogram, when I'm looking at one value, that's new value. Histogram is a value. Now, a trend line like this is also not very insightful because trend line should be used to show me change over time. But here in my data, I don't have a change over time. The case numbers has no chronological order. I don't have dates, so I should not use trend line. That's how you make your decision on your chart. Pie chart does not belong to using visualization for one numeric variable, so pie I don't have categories. Bar chart almost the same. Trend line I don't have time series needed. This is my tool. And I create a histogram and I start playing with it. That's how you make a decision on your chart. It's an art. Now look at this. Here you see I changed the layout. I want it to be 1 row and 2 columns. I want 2 separate. I want to have 2 charts. So in the matrix I say 1 column 2. That means 1 and 2. That's what I mean. Number 1 and number 2. and I need 1 row and 2 columns. So which one is better to visualize the count per state? This or this? Now you're looking at them together. Hey. What? One. Second, it's easier for our mind to look at bars and see differences than looking at those slides and identify differences. Here, even if I hide the numbers for you, you will be able to see some kind of differences between the bars like this, faster than you see the difference between this and this, and this and this, etc. Are they the same or not? Once you're asking this question, that means it's not good to for visualization. What about scale? Look when I change the scale using ylim in plot. Ylim is y limit. So if I use plot function only to visualize sales, it decides on the limits of the y acts on its own, based on the values of sales. So it picks one that is a little bit less than the minimum value and one that is a little bit higher than the maximum value. But using ylim, I told R I want the minimum of 0 and the maximum of 100,000. Although the maximum sales that I had was 20,000 or 20,000 something. So with increasing the scale, I cannot see this variability in sales anymore. And it looks as if they were all the same. The selection of the scale in the chart is very important. And this is called data visualization distortion. You distort the view and the visualization and you provide wrong information. It's the same data, the same function. Just one decision changes from correct to wrong. And sometimes this can be also misleading because it's showing me huge variation. But actually, is it really a huge variation? Because the minimum here is 10 and the maximum is 20. So all this variation is within 10,000. So maybe I need a little bit more than this, but definitely less than in terms of scale. Selection of scale, very important. All right. Let's do seven minutes break. Go. 7, 8. I was going to send now that say they physically person travel to Europe, all like coming to the case.
Yeah, man, tomorrow's gonna be like a recession.
I was even expecting that before, but now
Because okay, so people were expecting Trump to like say like what he's gonna do with policies and what
it was going there, now we're going fast. That's usually the hard code for
Okay, cool, thank you. So I asked one of the people, how the one solved it for something else completely different. And I asked someone straight up, how they did it for her, she didn't know. So I started lying. There.
Hi, is anybody from group 5? Sorry. Anybody from group 5? No one?
I'll tell you how you can do that.
What?
You can do that through Sakai.
I know, give me the message.
Oh, I make memories.
Oh,
Yo, the NBA just suspended their season.
fine, I didn't like.
Yeah, do you want to do it yours?
Oh, sorry, I just gave up the.
Yeah. Like a Google Doc.
Hey, the world's going to flames, bro. They just suspended the NBA season.